In this video, we are going to learn how to solve systems of linear equations using matrices. In this method, it is very systematic, and here we don't need to use substitution or elimination. We'll just focus on the matrix method. So, if we have three equations, let's say a1x plus b1y plus c1z equals to d1. Then we have a2x plus b2y plus c2z. Let's say this one is equal to d2. And then we have a3x plus b3y plus c3z equal to d3. So the left hand side of these three equations can be written in matrix form. So when we write in matrix form, it's going to tell us how we can solve it. So the left hand side can be written as a product of two matrices, and the right hand side can also be put in matrix. So if we write this in matrix form, we are going to have a1, b1, c1, a2, b2, c2, a3, so this will be our first. So remember, the left hand side will be written as a product of two matrices. So that now times x, y, z. We are equal to. So this one can just be following matrix d1, d2, and d3. So it is as simple as that. So now let's say let A in this first matrix A1, B1, C1, B2, B2, C2, A3, B3, C3, let X, E, X, Y, Z, and let's see just take the inverse of the matrix we are putting times C. So there is a condition here when the determinant of A is not equal to 0. So let's take an example. Let's take a system with two equations with two variables. So let's take an example. Let's say we have 2x plus 3y equal to 13, x plus 2y equal to 8. So this one is just two systems of equations. There are some with 3, there are some with 4 and 1. So this one just makes it easy to have two systems of equations. So let's take step 1. So to solve this, because we have to find x. So to solve So we know that AX is equal to C. Okay, so now we need to solve using the inverse. This is how we go about it, because we have to find x and y. We have to find the value of x and y. So we have to solve using the inverse, because x will be equal to A inverse of C. So we need to find the inverse of that matrix A. Okay, so to find the inverse, first you need to find the determinant, second you find the adjoint, and then the inverse. Okay, so let's have it. Step 2, you need to find the determinant of that matrix. Okay, so the matrix is 2, 3, 1, 2. So to find the determinant of this matrix, is just going to be 2 times 2 minus 1 times 3. That is all. We multiply the numbers at the diagonal and subtract from those at the non-diagonal. So this will give us 4 minus 3, which is 1. So that is a determinant. Now, we're just finding the inverse. It's nothing difficult. So we have step 2 to find the adjoint. Sorry, step 3 to find the adjoint of that matrix. So since it is a 2 by 2 matrix, we don't need to stress ourselves. We just go straight to the point to find the adjoint. So the adjoint of A, we switch the positions of the numbers at the diagonal. So since they are both 2, we just leave it like that, and we change the sign of the numbers which are not at the diagonal. So this is minus 3 and minus 1. So this is the adjoint. So step 4, we find the inverse of A. Okay, first you write your formula. The formula is very important. A inverse is equal to 1 divided by the determinant of A times the adjoint of A. So we have found the determinant, we have found the adjoint matrix. So now we put it in this formula. So we have that A inverse is equal to 1 divided by 1. The determinant is 1, so we simply have 1 times the adjoint, which was 2 minus 3 minus 1, 2. So 1 divided by 1 is basically 1. So this is 2 minus 3 minus 1, 2. So this is the inverse. But this is not all. Remember, we have to find the value of x and y. Okay, so we had something like AX equal to C, and to A was our matrix, X was our X and Y, and C was the other values. So to find this X, we have to have X equal to A inverse of C. So that is why we are looking for the inverse. So now we will take the inverse we got and multiply it by C. So A inverse is equal to 2 minus 3 minus 1, 2. And what was our C? Our C is 13, 8. That is a column matrix. 13, 8. Okay. So now X is equal to, we need to multiply these two matrices. Minus 1, 2 times 13 and 8. So let's see, since we are to multiply, we need to see what our product will give us. What is the order of the matrix of our product? First, what is the order of this matrix? This is a 2 by 2 matrix. And what is the order of this other matrix? It is a 2 by 1 matrix because we have 2 rows and 1 column. This 1, 2, and then only 1 column. So these two are the same. So our product needs to be a 2 by 1 matrix. So let's multiply and see what it gives us. So let's multiply. Remember, we are multiplying rows by columns. So this will be 2 times 13 minus 8 times minus 3. Sorry, plus 8 times minus 3. That's the first one. Next, we have minus 1 times 13 plus 2 times 8. So this is simple. Just take 2 times 13 plus minus 3 times 8. That will give us the first value. Then we have minus 1 times 13 plus 2 times 8. That will give us the second value. Okay, so now let us simplify it. So 2 times 13 is 26. 8 times 3 is 8 times minus 3 is minus 24. And then here we have minus 13 plus 16. So this gives 2 and 3. Okay, so our x is equal to 2, 3. Remember, our x is x, y. So x, y is equal to 2, 3. Now this takes us to equality of matrix. So since these two matrices are equal, that means x is simply equal to 2 and y is equal to 3. So it's very nice and clean. That's all. It's not difficult. So now let's go bigger. Let's go with 3 equations. Let's go with 3 equations. Now 3 equations with 3 unknowns. Up there we had only 2 unknowns, x and y. Now we are going to z. So let's have 3 equations. Another example. So we have x plus y plus z equal to 6. 2x plus y plus 3z equal to 14. X plus 2y plus 2z equal to 12. Okay, so these are the 3 system of equations. So the first step, we need to write them in the matrix form. We need to write it in its matrix form. So from the matrix form, we will know exactly how to solve it. So our A is, we take it according to the way we see it. From the first matrix, we have x is 1. Sorry, from the first equation, x is 1, y is 1, z is 1. We go to the second. X is 2, y is 1, z is 3. We go to the third. X is 1, y is 2, z is 2. This is our first matrix. Now our x will be the unknowns. The unknowns are simply x, y, and z. And our c will be 6, 14, and 12. So we know ax equal to c, and since we are to find the unknowns, x will be equal to a inverse of c. So now we need to find the inverse of this matrix. So that takes us to step 2. That is to find the determinant of a. Okay, so let me write back this matrix. 1, 1, 1, 2, 1, 3, 1, 2, 2. So to find the determinant of a 3 by 3 matrix, we write plus minus plus minus plus minus plus minus plus. So is our work. So this first row, remember we are taking rows. This first row has 1, so it's going to be easier for me. So let's take the first. The first has a positive sign, positive 1 times. We cancel its rows and columns. We are left with 1, 3, 2, 2. So this is 1, 3, 2, 2. The next one has a negative number times. We cancel its rows and columns. This and this. We are left with 2, 3, 1, 2. 2, 3, 1, 2. And the next one has a positive number, positive sign, sorry. We cancel its rows and columns. 2, 1, 1, 2. So now we are taking their determinants separately. So the first case, so I'm going to go slowly. So we are dealing with that first. Let's find the determinant of each first in order not to confuse. So we take the determinant of that first, which is 2 times 1 minus 3 times 2. The second case, it's 2 times 2 minus 3 times 1. And the third case, this is 2 times 2 minus 1 times 1. So this is 2 minus 6, 4 minus 3, and 4 minus 1. So that one is minus 4, 1, and 3. Okay. So that is that. Now we put it back in to our main equation. So the first one was minus 4 minus 1 into 1 plus 1 into 3. This is minus 4 minus 1 plus 3. So this gives us minus 5 plus 3, which is minus 2. So the determinant of A is minus 2. Okay, so that is the second step. Now let's go to the third step, which is to find the adjoint of A. And since this is a 3 by 3 matrix, then we have to find the matrix of cofactors. That means we need to write that matrix 4 times. We have 1, 2, 3, 2, 1, 3, 1, 2, 2. The first time, 1, 1, 1, 2, 1, 3, 1, 2, 2, 1, 1, 1, 2, 1, 3, 1, 2, 2, 1, 1, 1, 2, 1, 3, 1, 2, 2. We eliminate its outer boundaries. So we are left with 1, 3, 2, 1, 2, 2, 1, 2, 1, 1, 1, 1, and 1, 3, 2, 1. So now we group them into 2 by 2 matrices. So we take the first 2 by 2. This is the first one. So we have 2 times 1 minus 2 times 3. Take the second, 1 times 3 minus 2 times 2. And we take the third, 2 times 2 minus 1 times 1. Let's take the next. 1 times 2 minus 1 times 2. Take the next. 1 times 2 minus 1 times 1. Take the next again. 1 times 1 minus 1 times 2. We take the next. 1 times 3 minus 1 times 1. The next. 1 times 2 minus 1 times 3. And the last. 1 times 1 minus 1 times 2. So this gives 2 minus 6, 3 minus 4, 4 minus 1, 2 minus 2, 2 minus 1, 1 minus 2, 3 minus 1, 2 minus 3, and 1 minus 2. So in general, this is 2 minus 6 minus 4, 3 minus 4 minus 1, 4 minus 1, 3, 2 minus 2, 0, 2 minus 1, 1, 1 minus 2 minus 1, 3 minus 1, 2, 2 minus 3 minus 1, and 1 minus 2 minus 1. So that is the matrix of cofactors. Now the adjoint of A is equal to the transpose of the matrix of cofactors. So now we take the transpose of that matrix. So the adjoint of A becomes, so the rows becomes columns, minus 4 minus 1 3, 0 1 minus 1, 2 minus 1 minus 1. So that will be our adjoint. Now let's look for the inverse of this matrix. So the inverse of this matrix is 1 on the determinant times the adjoint. So what was our determinant? Our determinant was minus 2. So we have minus half times minus 4 0 2 minus 1 1 minus 1 and 3 minus 1 minus 1. So this takes us to the next step, step 4. Which is to take A inverse times C. So X is equal to minus half minus 4 0 2 minus 1 1 minus 1 3 minus 1 minus 1 times C. What was our C? 6 14 and 12. Okay, so now let's do this multiplication first before adding this. There's no difference. It's going to give us the same answer. So this will be minus half now into, let's do the multiplication. So minus 4 times 6 plus 0 times 14 plus 2 times 12. That will give us the first value. Minus 1 times 6 plus 1 times 14 plus 12 times minus 1. Second, 3 times 6 plus 14 times minus 1 plus 12 times minus 1. Okay, so now let's simplify 8. So minus 4 times 6 is minus 24 plus 0 plus 24. That is the first value. Minus 6 plus 14 minus 12. And then 18 minus 14 minus 12. So this is minus half. So minus 24 plus 24, that gives us, so let's just say minus 24 plus 24. So minus 6 plus 14 gives 8 minus 2, 18 minus 4, minus 14, that gives 4 minus 12. To simplify it further, minus half into is 0, 8 minus 2, 8 minus 2 is 6, and 4 minus 12 is minus 8. So now we can multiply them by minus half. So 0 times minus half is 0, minus half times 6 is minus 3, and minus half times minus 8, that is 4. So that is our x. Okay, there's a mistake here. Here was 12, so this is supposed to be 12. Let me just cancel it. So this is minus 12. So this is 8 minus 12. And this is minus 4. So this changes to minus half times minus 4 is 2. So that is it. So that is x. So x is equal to x, y, z, which is equal to 0, 2, 4. So we can conclude that x is equal to 0, y is equal to 2, and z is equal to 4. So that is how we go about it. So it's very easy. So remember, the first thing when giving system of equations, you need to write it in a matrix form. You look for the inverse of that matrix which you have gotten, and then you multiply by the other numbers. So that is all for today, guys. Thanks for watching this video, and I'll see you guys in the next video.